Much of the time, we're not even aware of all the things around us that we aren't attending to. Attention often filters out distractors early in processing so we can more readily focus on the important features of the sensory world, leaving us completely unaware of the clutter or unimportant features of the scene. The result is that we often think we're seeing everything in front of us, but that's not actually true. Here we have some simple demos that can illustrate how attention shapes our perception and how much can change without us noticing at all. You can show these demos in your class, and for some you'll be able to collect experimental data in class if you want to. More on how to run those experiments and analyze the data in the separate module on classroom activities. The first video will clearly illustrate both the cost side of attention and our power to voluntarily decide what we attend. In this video, the viewer chooses to attend to a certain color based on the instructions, to the detriment of perceiving other things happening in the scene. This is an example of voluntary or top-down attention based on a feature, the color.
The monkey business illusion. Count how many times the players wearing white pass the ball.
All right, so just follow these on-screen instructions.
The correct answer is 16 passes. Did you spot the gorilla? For people who haven't seen or heard about a video like this before, about half missed the gorilla. If you knew about the gorilla, you probably saw it, but did you notice the curtain changing color or the player on the black team leaving the game? Let's rewind and watch it again. Here comes the gorilla, and there goes a player, and the curtain is changing from red to gold. When you're looking for a gorilla, you often miss other unexpected events. And that's the monkey business illusion.
Next, we'll look at an example of change blindness. These videos, in which a brief blank frame prevents you from noticing a major change in the scene, show that our brains don't really store the full scene for comparison to the subsequent image. So I'll give you a second, and you can look around and try to find the change. Hopefully by now you've seen that this engine under the wing is appearing and disappearing over and over. You're most likely to notice the change if you happen to be looking directly at it when it appears. In other words, overtly attending the location where the change occurs. But if you try, you can accomplish the same thing while holding your gaze fixed in the middle of the image and covertly shifting your attention around. Usually in this case, it will take several tries to detect the change. See if you can detect the change in the next example while keeping your eyes fixed in the center of the screen. Maybe by now you've noticed that it's these bushes just over the Sphinx's shoulder. We'll post links to many more of these change blindness videos in the resources section so that you can show new ones to your class. In the gorilla demo, your voluntary choice to attend people wearing one color kept you from noticing other things. In this next demo, no explicit instructions about what to attend are given. Instead, the sudden appearance of a stimulus draws involuntary attention to that location automatically, and it will linger there for a short time. First described by Michael Posner in the 1960s, these cues are now commonly referred to as Posner cues and only work when the cue and the test stimulus occur relatively close together in time. This is an example of involuntary or exogenous attention. If a second stimulus appears at the same location as the Posner cue within a fraction of a second after the cue, your perception and ability to respond to this second stimulus will be enhanced because your attention is already directed to this location. Let's look at a demonstration. All right, so you're going to indicate, in this case, if you see a stimulus in the left or right box. Keep your eyes fixed on the cross in the center. You're responding to that green go, and you don't care explicitly about whether there was an X on the screen or not. But whether that X appears on the same side as the go signal or the opposite side as the go signal is actually going to affect your speed in responding. You can see the effect of cues by having a subject respond to that second stimulus, like the go cue in the example, and then comparing the reaction times or accuracy of reporting the appearance of the second stimulus when the preceding Posner are cued at the same location or a different location. When the Posner cue and the test stimulus are at the same location, responses to the test stimulus will be faster and reporting accuracy is enhanced. Data for an experiment using Posner cues can be collected and analyzed in the classroom. More on that in the classroom resources section.